Thank you. Well, first thing, I want to thank NETWAYS for inviting me to give in this short tutorial on OpenNebula. I'm going to try if I feel like Madonna with this thing on. I'll do my best anyway. Okay, so, well, for those of you that don't know about OpenNebula, it's a virtual machine, a distributed virtual machine manager. So it basically helps you turn your physical infrastructure into a virtual infrastructure to help flexibilize your services and build private, hybrid, and public clouds. So this is a short tutorial. My intention was to give some sort of hands-on, but with just an hour, I cannot. So I'll briefly talk about OpenNebula and its place in the cloud ecosystem, some hints about the installation and configuration of the software, and then I'll talk a bit in length about how you can build a private cloud using this software, and also how you can extend your local infrastructure power with some external service provider, like for instance Amazon or Elastic-Host, to do some cloud bursting and thus building a hybrid cloud. Also, I'm going to talk a bit about how can you put some cloud interfaces on top of your OpenNebula installation, so turning your private cloud in a public cloud, so you can share your unused CPU and memory power to external users. And also some, I will end with some features that is from the latest version that just came out last week. So please feel free to interrupt me at any time. I mean, I know questions are afterwards, but this is a kind of a technical tutorial, so if you have any questions, yes, I'll be happy to answer them anytime. Okay, so where does it fit OpenNebula? So this is like the normal cloud stack. You have 3 layers. You have the software as a service layer that it's intended for the end user, that doesn't care about which hardware or software is he using. He just cares about the user interface and that it works. That's built upon another layer that is called the platform as a service, that it's intended to the developer, that will just focus and make some code, and then he will just deploy it in the cloud, not caring about hardware requirements or anything. He will just have a virtual machine or some sort of Google App Engine or something like that to run its code. Okay, everything is supported then by the infrastructure as a service, which is what basically turns your physical infrastructure into a virtual one. This is where OpenNebula comes into play, and this is intended for system administrators that want to flexibilize the use of their infrastructures. Okay, so this is in one slide what basically OpenNebula does. So OpenNebula, it's managing your physical resources, being that the physical storage for storing images for your virtual machines. Also, obviously, the physical machines being compartmentalized by some hypervisors. And also take care of the physical networking by building virtual networks to connect virtual machines. So on top of that, OpenNebula builds a virtual infrastructure. A virtual infrastructure is intended to run virtualized services. So for OpenNebula, a service is just a conjunction of virtual machines interconnected by a virtual network. So you can create services like web servers, maybe some HPC batch scheduler or something like that. You can create that in a flexible way, meaning that you can have rules that will scale your service, meaning it can grow if the demand is high, or it can decrease if the demand is getting low. OpenNebula doesn't provide all the mechanisms to do that. That elasticity should be managed by a component that will be sitting on top of OpenNebula that we call the service manager. But OpenNebula gives you the means to operate the low-level infrastructure as a service stuff. Okay, so our vision of the cloud is not something that is going to break completely what with what we have beforehand, but we rather think it's an evolution of the normal data center. Because of that, there's things to take care of. So there's constraints from existing infrastructures and processes, and there's also requirements from usage and deployment scenarios. So this ends up rendering a solution that needs to be flexible enough to be able to integrate with different components and processes. So the idea of OpenNebula is that it's not a solution that works straight out of the box, but it requires a fair deal of tuning to be able to be a toolkit general enough to fit in all possible data centers. Okay, a bit of history on OpenNebula. It is one of the products of research projects in the European Union. So it basically came out as an artifact from the Reservoir project, which is the cloud flagship project in the European Union. It's a result of many years of research. I mean, we've been doing that since 2005, and we just released the first version in 2008, and as I just said, the version 2.2 just got released last week. It is completely open source software. It's been distributed by the Apache 2 license, and it's packaged for the main Linux distribution. So even though you're not going to get the latest version, you can install it from repositories from Ubuntu, Debian, SUSE, and we are working in the Red Hat EPIL one. We provide support on a best effort basis. We have mailing lists and a development portal that anyone can get an account with and present patches or feature requests. The roadmap is driven by the community and also by research projects. So we are involved in several projects with different requirements, and we try to build our roadmap based on those projects and also from what the community demands. We have a kind of a large community for being more or less a young project, and we also feature an ecosystem with third-party developments, so with components around OpenNebula that can help you to build a final solution for your cloud. And yeah, just to finalize this slide, just saying that the long-term sustainability is kind of ensured by project funding and also by commercial sponsors like C2G Labs. Okay, why you should choose OpenNebula? Well, it has capabilities for cloud management, obviously, also for integration, which is important. All the architecture is kind of plugin based, so you can develop your own extensions to OpenNebula kind of easily to integrate that with other components, like, for example, authorization mechanisms or new storage backends or things like that. It's being certified and tested, so it can be used, and it's being used in production environments. Also, you can take advantage of the cloud ecosystem components, and again, it's fully open source, so you can fork it, you can do whatever you want with it. Okay, so this is kind of a high-level vision of the architecture of OpenNebula. You can see it has a core, which is a daemon written in C++, which is very well tested and kind of we intended to make it minimal. It communicates with different drivers to perform different operations in the infrastructure. So it has a driver for communicating with the compute, that's the hypervisor. Also drivers to communicate with the storage, so have drivers to do SSH to transfer the images to the end node, or drivers to take care of an NFS export, and things like that. We also have drivers for networking, for security, and that cloud one is drivers to communicate with external cloud providers, like, for instance, Amazon. We'll talk a bit about that afterwards. On top of the core, there's an XML-RPC interface where you can control every aspect of OpenNebula. On top of that, you can build some cloud APIs which basically are going to hide some of the details on your physical infrastructure for the external users. So it's basically going to have a subset of all the functionality offered by OpenNebula, so you can offer that to external users like Amazon does, for instance. So in Amazon, you cannot, basically, you cannot see which node your virtual machine is running on. You don't really need to care about that. But with OpenNebula in a private cloud, you can do that. It doesn't make sense for external users, but it may do for internal users, and it definitely does for the system administrator. Using that XML RPC API, we also have communication with the scheduler, which basically it's an external process that is deciding which is the optimal placement for the virtual machines on top of your physical nodes. And that's more or less the architecture of OpenNebula. We try to abide to as many standards as possible to foster interoperation. So we implement some of the most known interfaces for cloud computing, like OCCI, also the Amazon EC2 query service. And we also have plugins to talk with different service providers, like, for instance, Amazon or Elastic Hosts. And also we have a plugin for Delta Cloud that helps OpenNebula talk with different service providers, like Rackspace or GoGrid or Terramark, and some others. Okay, so these are some examples of components in the ecosystem. We have a scheduler being done by Borja Sotomayor of the University of Chicago, which basically offers OpenNebula users the ability to do advanced reservation on their virtual machine. So being able to say to OpenNebula, I need this virtual machine to be running Saturday from 5 to 6, and you better have a slot for me. There's also some other components for like graphical user interface doing by Sarah in the Netherlands. There's a service manager built by Telefonica, it's called Claudia. There's also some tools to better install OpenNebula done by C12G Labs. There's a really nice app by the Clemson Institute that is running in CERN now. That is basically intended to do parallel copies of the images using the SSH protocol. Okay, so that was the introduction, more or less, of OpenNebula. Now I'm going to talk a bit about how you can install and configure OpenNebula in your local infrastructure. Okay, so this is an idea of a deployment of OpenNebula. You will have a front end where OpenNebula is going to run, which basically acts as a classical cluster front end. It's going to be the access point for the sysadmin and the end users to manage and to use the cloud. Okay, so this front end will have to talk with the different cluster nodes. These cluster nodes are the physical servers with a hypervisor installed, and possibly some export of NFS or some other distributed file system to hold the images for the virtual machines. So basically, the front end is going to talk with these different physical servers using SSH protocol or Libvirt, or depending on your hypervisor. If it's VMware, it's going to talk using SOAP, for instance. And it's going to perform the life cycle of the virtual machine from the very beginning. So it's going to transfer the image to the physical server. It's going to talk to the hypervisor and say, okay, I want this virtual machine to be launched. Then you can control the life cycle of the virtual machine by stopping, resuming, migrating, live migrating, all those operations. And then you can end up the life cycle of the virtual machine and save the image or the disks of the virtual machine that you consider that has useful data. You can take them back to the central image repository. Okay, so if you choose to install OpenNebula, you will have to configure, you have to touch the following files in order to get it working. So in etc1d.conf, you will find the general configuration, stuff like which port is going to listen, the XML RPC interfacing, which is going to be the polling interval that OpenNebula is going to use to poll the physical servers and the virtual machines. And more importantly, which drivers are you going to use in your physical infrastructure? So you can activate drivers, for instance, for KVM, or drivers for Shen, or for VMware. You can also activate drivers for doing SSH, or NFS, or LVM. And you can have different information manager drivers, like, for instance, in the latest version, you can use Ganglia to monitorize your whole infrastructure, which greatly improves the scalability of the solution. There's also for each driver some configuration files that will make default. For instance, in the virtualization driver, it's going to make defaults, like if you don't set the amount of memory of your virtual machine, then you're going to have a default there saying, okay, default it's 1 gig virtual machine or something like that. There's also configuration files for the transfer manager, so you can modify or nullify some operations. Like, for instance, if you don't want OpenNebula to delete any image, you can just set the action of delete to some no operation or empty script or something like that. And the same goes for the information manager. You can set some particular configurations, like, for instance, in the Amazon EC2 driver, you can set which it's the maximum capacity you want to use from Amazon, so you don't lose a lot of money by just outsourcing virtual machines. Okay, so that's more or less how you can install and configure OpenNebula. The installation part, it's getting easier and easier. Now it's just, if you have a common Linux distribution, you can install it directly from a central repository, and you have to forget about dependencies and things like that. So any questions so far? Is anyone understanding me, or is my Spanish accent getting in the way? Well, okay, I'll carry on. So private cloud with OpenNebula, administration and basic usage. Okay, so to create a private cloud, after you have OpenNebula installed and configured, you have to do this set of bullet points. You have to add your physical hosts to the OpenNebula system. So if you have, say, 5 physical machines that you want to use as the substrate for your cloud, then you have to tell OpenNebula about them. And you have to tell them about how OpenNebula can interact with these servers. So basically, when you add a host, you define which drivers you are going to use. The transfer, the information, and also the virtualization driver. So you can have more than one type of physical server. So you can have, for instance, OpenNebula managing a set of KVM physical nodes and also a set of Shen physical nodes, one of them using SSH, the other one's mounting an NFS partition. There's no problem with that. And that's going to be completely transparent to the end user. So he will just send virtual machines, and he wouldn't care where this virtual machine is running in a Shen environment or KVM, or that's for the system administrator to tune. Also, you will have to create users so they can submit virtual machines and manage them. You can define virtual machine images, so the end users don't have to create their virtual machines, but rather use one set of predefined ones. You have to define virtual networks, so the virtual machines will be able to talk with them, among them. You will also have to create a virtual machine template that's basically going to define a set of capacities, like CPU, memory, and also which virtual machine images and which virtual networks it's going to use. And of course, you will have to launch these virtual machines. Okay, so component by component in the cloud, you'll have a hosting OpenNebula, which is a resource with capacity. It's able to run VMs, and it must be configured as an OpenNebula node. You'll have a name and a set of drivers. From version 2.0 onwards, you have the ability to do logic clusters, so you can basically group one set of physical machines that have some hardware characteristics that they share. So you can then have virtual machines that are going to run just in the cluster where the big servers or the small servers are. And these operations, the host-related operations, are managed with the one host command. So, okay, I don't really have the time to show you how this one host command works. I'll rather explain, give some hints, give some examples of the cloud commands afterwards. So let's carry on. Okay, a user is something with name and password. Not much more than that. We also have in the latest version an authorization module that you can plug into your LDAP, or you can also have the users authorized using the SSH keys, or you can even develop your own authorization driver to integrate with some other authorization framework like Kerberos or things like that. And those are managed with the one user command. Okay, so a image in OpenNebula, it's basically an ISO file that is containing a repository, and also with a set of metadata that it's going to help OpenNebula to use correctly this image, like, for instance, which is the target, the desired target of the image, like where it's going to end up in the virtual machine, like in dev SDC or things like that. Also, there's some sort of kind of basic ACL for the image, virtual networks and virtual machines, that basically you can define your image to be persistent or public. So if it's public, then everyone can use it. If it's persistent, then all the changes that is made to an image during the life cycle of one virtual machine are going to be saved back. So next time a user wants to launch that virtual machine, he could see the changes or the new software or things that you can declare it as non-persistent, so it's going to be a one-off. You fire the virtual machine, do whatever you want, turn it down. Next time it's going to be a clean virtual machine. And these images are managed with the one image command. Yeah?
There is an image transfer from a main repository, as understood. There is an image transfer from the main repository to the hypervisor host?
Yes. Well, depends. If you're using an SSH-based driver, then yes, you have to copy them. If you're just mounting an NFX export, then you don't have to copy.
It's going over the network?
It's going over always, yes.
So, the question is, how do you care about high availability? You say the image can be persistent. Meaning in the life cycle of the virtual machine, the image is I guess, transferred back after the image, the virtual machine is shut down.
Yeah, if you're using SSH. Sorry?
What happens if your hypervisor breaks? What happens if your hypervisor crashes?
You're in trouble. Okay. Yeah. I mean, we provide some sort of mechanisms for high availability. We have hooks that can be triggered. For instance, OpenNebula is always monitoring virtual machines and hosts. So if it detects that one host is down, you can have a trigger in place that is going to launch that virtual machine again.
But not the same image, but a new problem.
That's up to the service manager to decide what's happened if one image goes down.
But you're using a hypervisor, you're losing the images on the hypervisor.
Well, not really. If you're using SSH and the host is down, then yes, you lose the image. No way around that. If you're using NFS and the hypervisor crashes, you can launch that same image in other node. So it pretty much boils down to how your system is configured, what is your service, and what have you done in terms of high availability.
If you have an NFS repository, are you starting the images directly from the NFS? Or is it also...
It's configurable. You can do that, or you can copy them in local.
But as soon as you copy, you're away from the main repository, so if your host goes down...
Yes. So For one solution, it's good because if you have a copy in local, the virtual machine performance is going to be much better. But then if the host goes down, then you lose it. You can have some other mechanisms like DRTB or things like that. We try to cover some, but it's difficult to cover all the scenarios. Okay, virtual networks basically how this works is OpenNebula has a sort of a DHCP built-in manager that basically what does is for each virtual machine that is attached to a virtual network is going to give a set of MAC and IP addresses. So what happens is when a virtual machine fires in a server, it's going to be attached to a software bridge that is defined by that virtual networks. So if you have two virtual machines running in different hosts attached to the same network interface that is supposed to be shared using a switch or something, they will be able to talk with each other. You can define also network interfaces that can be public, so the virtual machine can see the internet. And well, virtual networks also, they can be isolated at level 2 using EV tables and hooks. So basically, this would be a hook that is called on running, so when the virtual machine is fired and it's running, then some EV table rule is going to set up so this virtual machine can only see other virtual machines in the same virtual network. So you can have a fixed virtual networks where you define in a list manually a list of IPs. This is useful for instance, if you have a limited set of IPs, of public IPs for your virtual machines. And also you can have a ranched virtual network. So that's basically you give a base address and a network mask, and you will have your virtual network ready to start leasing IPs. And the bridge I just talked is managed by the 1vnet command. One thing about how this is handled by the virtual machines is, well, OpenNebula doesn't want to mess with your virtual machine. I mean, it's not going to do anything to your image or to virtual machine. It's all up to the user, or more likely to the sys administrator. So the only thing that OpenNebula can do to a virtual machine network-wise is to set a MAC hardware address to the hypervisor, saying, okay, this virtual machine is gonna wake up and it's gonna find that it has a 2 or 1 or none network interfaces, and they will have these MAC addresses. So it's up to a boot script or something like that to figure out an IP address out of this MAC address. I'll give an example in a bit. Yeah.
Question about the virtual networks. Is OpenNebula supporting the VLANs for virtual machine?
Not yet. We're working on that on OpenW Switch, I think it's called. OpenV Switch. Sorry? Yeah, but for the moment, no. No, we don't manage that. Okay, a virtual machine. Well, it's a capacity in terms of memory and CPU, a set of network interfaces, a set of disk images, and also can be a state file, which is basically a memory dump of the state of the virtual machine when you choose to save and stop it. All the log files, images, state files are stored in one location bar VM ID. This can be shared to the physical nodes using NFS, or it can just live in the front end. So basically in the front end you will always have all the logs of every virtual machine running in the system. And the virtual machines are managed with the 1VM command, where you can say things like submit the virtual machine, stop it, migrate it, blah, blah, blah. Okay, this is a very simple example of a virtual machine template. So find a name, you say, okay, I want to use just a fraction of a physical CPU. This is kind of tricky, but I don't have the time to get in detail about that. The memory that in megabytes that the virtual machine is going to have available, and also, okay, just we are saying here, I want to use this image that is already uploaded in the image repository, that is a TTY Linux, and I want to use one network, virtual network called 1TD that I created beforehand. Just like an example, you can set some other things, like for instance here you can set a PNC consoles. So if you don't have network running and you want to figure out why, well, you have the tools to do that. This is offered by all the hypervisors. Okay, a bit more then on virtual networks. So when you define a virtual network, basically what happens is that your virtual machine ends up with a MAC address. So we also provide the scripts for several Linux distributions that will perform this mapping over here. So basically, there's a prefix that you can define in oneday.conf that is going to be shared by all the virtual networks. And then from the last 4 bits of the MAC address, it's going to figure out the correspondent IP. So it's a simple script that you can set at boot time in your virtual machine. So you end up with virtual machines having the IP addresses that you set up in OpenNebula.
How do you deal with VMware MAC addresses?
Sorry?
How do you deal with VMware MAC addresses?
Same thing.
As far as I know, they need a special MAC address.
Yeah, you can override that if you want, but you can put the prefix you want. So it's a bit more tricky, but can be done. I think it's explained in OpenNebula documentation how to deal with that. Yeah, it's okay. I remember. It's basically in the template when you create a virtual machine in VMware, you create something called the .bmx file, which is kind of the template. You can set there a value saying, I don't care about the Ethernet, the MAC value. So VMware will just swallow that. Okay, so that was the public cloud. I have maybe the time to show you. Oh. Some of the commands we've been talking about. Okay, so this is the one hosted utility. So basically, this will help you add some physical hosts to OpenNebula. So basically, well, I don't know if I have a. Okay, so this will be the list of physical hosts. This is a clean installation, so I don't have anything. So if I wanted to add one host called, for instance, KVM1, I will do something like this. So add or create, I don't remember now. KVM1, this should be the DNS or something that can be pingable, for instance. So OpenNebula is going to use that name to reach the virtual machine using SSH. And I will add it with some drivers. So for instance, the SSH driver, KVM driver, and the SSH transfer driver. Okay, so I have here my machine. Oh, a second. Okay, this is going to fail because that machine doesn't exist. After the polling interval is done, the state is going to change to error. Otherwise, you're going to fill the available CPU, the total memory, and all those things. You can have extended information about the host using the show command. You can delete it, enable, and maybe more interesting will be to see. Okay, this is the main configuration file, the 1d.conf. So you can set here things like which is going to be the host monitoring interval. So you set this value to low and you have lots of hosts, then maybe there's going to be a bottleneck in the OpenNebula front end. and the other way around. Also, the same applies for VM polling intervals. So these are things that you should tune depending on your infrastructure. VMDIR, port, well, okay, you can use several databases backend. So this is used to store the information about your infrastructure. So OpenNebula, if it crashes, you can just fire it again, and the data will be there. The virtual machines will be running still, and OpenNebula will be able to connect to them and keep on managing them. So you can have a how do you say that in English? Okay, you can have MySQL or SQL that. And we are working in Postgres and some other backends. Okay, so let's skip this. Blah, blah, blah. The MAC prefix for all the virtual networks, the default network size. Okay, the default path for the image repository, blah, blah, blah. Okay, this is the interesting bits. So this is how you enable drivers in OpenNebula. So basically here we are saying we have a driver for KVM that is basically going to run this script, which is, well, this is not a script, it's a wrapper for a Ruby program that it's able to talk with a physical host and extract information using probes. So there's a set of probes that we provide, but you can make your own to monitorize some other aspects of the physical host. For instance, we provide simple scripts to take out the CPU consumption or the memory consumption or the model name of the physical host, but those are simple scripts that basically output the information in attribute equal value fashion. And well, I guess what I mean is that it's really easily extendable and customizable for your needs. Okay, we provide others for Shen. This is it2, I'll talking a while about it. Okay, and these are the virtualization drivers. So this one is also for KVM. So this is going to be a script that is going to be able to talk with a KVM hypervisor and tell it, I want to run this virtual machine with this image, I want this MAC address, I want some other things, define it in the OpenNebula template. Yes, and then it's the transfer manager drivers. This one is for NFS. So basically this is the one that understands how your configuration is done NFS-wise. So basically it's going to, if you set an image like being non-persistent, then it's not going to transfer the image back. If you decide to clone your virtual machine, it's going to copy them. Even if there's available in all the physical nodes, it's going to make a copy so different virtual machines can run the same image, but not the same image, but a copy of that, and things like that. For SSH, there's drivers for LVM. These are the hooks. These are really interesting for making things like high availability or to make things like virtual network isolation. So basically, what they are scripts that are triggered through some states of the virtual machine. So, for instance, when you create a virtual machine, you can have a script that's going to notify the user via mail, for instance. When the virtual machine is running, you can have the EV tables script to isolate the networks. You can have a shutdown script to, can imagine now, stop, done, failed. This is one of the good ones. So you can define your infrastructure. So if a virtual machine fails for any reason, it's going to be restarted elsewhere, for instance. So these are hooks for virtual machines, but there's also hooks for hosts. So if a host goes down, we provide the scripts that are going to make all the virtual machines running on that host to be relaunched elsewhere. Also, the disabled hook is very interesting. So if you want to do some maintenance on one host, then you just disable it, and OpenNebula will also migrate the virtual machines somewhere else. So you can shut it down and set another disk or whatever. Okay, there are examples of hooks. And this is the authorization manager, which basically lets you integrate the users in OpenNebula to some other external authorization mechanism. We provide some, well, I said that before, for LDAP and SSH. Okay, so that was more or less an overview of the private cloud. If you run out of resources in your local infrastructure, you may want to extend by paying to some external service provider, for instance, Amazon. To do so, it's not as straightforward as it may seem, because, well, first of all, if you don't want a huge amount of downtime, you will need to have a copy of the virtual machines you are running in-house already uploaded to S3. So some use cases we developed to show how this hybrid cloud can be used could be like, for instance, the one we did with Sun Grid Engine. Well, sorry, it's a Oracle Grid Engine now. And basically with that, the use case was you have your local infrastructure running OpenNebula with a virtualized SunGrid engine on top. So you have a virtual machine running. Well, everyone knows what SunGrid engine is? No? Okay, it's basically a scheduler for batch jobs. So it's used in HPC, in high performance computing, to manage a farm of nodes to give them grid jobs, more or less, cluster jobs. Okay, so you can run this infrastructure virtualized. And this is very useful because you can have a SunGrid engine cluster that's going to increase if the load is getting higher, or can decrease if the load, if it's the other way around. So you can, our use case was that virtualized infrastructure running part on your local infrastructure and part on Amazon. So the tricky bit is to build a service or build the images so they work like that. So for instance, OpenNebula, if you say, okay, I want to increase this service and I want you to send some more nodes to Amazon, then it's just going to fire a virtual machine, and that virtual machine has to be able to communicate back with your SunGrid engine front end, engage in some sort of open VPN, so everything looks like it's in the same local area network that's needed by SunGrid engine, and I guess, but most of the service that can be run. And in that way, then yes, you can have a hybrid cloud deployment. But it's not just a matter of setting OpenNebula, but you also have to set your images and your service to work in conjunction. So it's really nice when it's set up, but it takes some work. Okay, so this is more or less the idea. So you will have your local resources, your cloud provider, OpenNebula sitting on top of building a virtual infrastructure where basically the nodes, I mean the front end doesn't know if one node is in your local infrastructure or in Amazon, doesn't care. For it, every virtual machine is running in the same VPN. Okay, so this is basically what you have to uncomment in your 1D.com file to activate the EC2 support. So basically, the virtualization manager for EC2 it's a script that basically is using the EC2 API to communicate Amazon, like, I want you to run this AMI, I want you to stop it, I want you to open these ports, things like that. There's also the information manager. Okay, so for OpenNebula, when you add this hybrid cloud possibility, basically what you're doing is telling OpenNebula there's a new host, you may call EC2 or EC2 U West or whatever you want, which has this capacity. So you have to say it can be a huge host, like a host with 1 tera of RAM, and I don't know, huge. You can just limit the number of instances of each type, so OpenNebula doesn't say, okay, I'm going to just stuff all the virtual machines in this huge host, because the scheduler is doing some greedy algorithm, and everything will end up there. You can also develop some new policies that we don't offer, but the scheduler is flexible enough to set them, where you can say, okay, I prefer not increasing the service more than 5 VMs by a factor of the cost, for instance. And well, the transfer manager is going to be dummy, because the images have to be preloaded in S3, otherwise there's no reason for this. Okay, so how this can work with the same OpenNebula template. You can have a template that can work for your local infrastructure, so defining which image has to use, which CPU, which capacity, and if that image ends up in the special host that is EC2, then you can set this sort of information. What's the AMI? What's the key pair to access the instance? What ports do I want it to be open? Which is the instance type I want to use in Amazon? Also, if I have elastic IPs, I want it to have this IP. And you can define different availability zones in OpenNebula, so you can use, for instance, the one from Europe or things like that. That's more or less what I have on hybrid clouds. I just have like 15 minutes left, so move on to the public cloud. So public cloud on top of OpenNebula is basically just a set of interfaces that you can set up to access your local private cloud. So you can maybe want to do that to offer your computing power to some external users, and well, you can charge them for that. We provide some accounting mechanisms, so you can keep track of which users run which virtual machines on which hosts, and you can bill using that. This is a little schema on how the cloud interfaces are built. So it's basically, well, we provide basically the important ones are the EC2 query interface and the OCCI. The OCCI interface. It's standard by the Open Grid Forum, which basically dictates how the resources like network, compute, and the storage should be treated. Okay, so let's start with the EC2 one. Basically, what we did is we built some sort of query web service on top of the OpenNebula Cloud API, which can understand the EC2 query protocol. So you can use the Amazon tools, although it's forbidden by them, but there's some set of tools we provide and also provide by some other projects, like for instance Eucalyptus. You can use those tools to communicate with the OpenNebula instance. So you have all it is a subset of all the EC2 query interface, but you can do things like describe instances, describe images, run instances. I don't know if you are familiar with the EC2 query interface or the API. Yeah? Has anyone launched a virtual machine in Amazon ever? Okay, good. So basically you can operate with an OpenNebula cloud the same way you operate with Amazon. Yeah, okay. This is an example of how you set the Econ service, which is how we call the EC2 query server. Well, yeah. You basically give it the endpoint of the OpenNebula installation. You give it which is the server you want to be this service to be listening on, and the port. Also, it features a little database well, this thing is being overridden in the latest versions. It's directly going to use the storage facility that OpenNebula has already implemented. And also you have these templates. These templates are basically ERB files. If you're familiar with Ruby or you ever done some web programming with ASP or things like that, this is basically a template with some placeholders. So that gets filled with information you want to give it at a given time. So this is useful to have different templates with different configurations. So you can, when you decide, okay, I want an instance type to be of type KVM large and with more than, I don't know, 4 teras of disk space. So you will end up with a template that OpenNebula understands with those requirements. So basically the end user, when he sees that template, he can choose, and OpenNebula will take care of having his virtual machine running in the desired set of hardware. So this is kind of a simple but very powerful mechanism to offer what's available in your local infrastructure to the end users. So these are basically a mimic of the EC2 tool. So you can upload images, describe them, register them. You can run instances based on those images. Well, so this kind of cloud APIs, what it does is a subset of what can be achieved in a normal cloud OpenNebula environment. So, for instance, using the EC2 interface, you lose a lot of functionality. For instance, you cannot have more than one virtual machine with more than one disk. You cannot define virtual networks between them. So it is interesting to offer it for the end user, but it's not really useful to run in a private cloud using this kind of cloud API. Okay, so maybe, oops. I can show you. We have a dummy cloud. It's basically an OpenNebula cloud running with some dummy drivers that is basically saying to OpenNebula at the time, yeah, all these operations are perfect. We have a public URL, it's cloud.opennebula.org. You can all of you can get an account. Just request one, and I'll grant it immediately. So you can. The thing is that you can basically try out the different cloud interfaces that OpenNebula offers. So we have set up the EC2, the OCCI, and also the graphical user interface that we just released. It's called Sandstone. That is aimed to system administrators and private cloud users. So it basically gives you all the functionality of most of the functionality that OpenNebula offers, not like the cloud interfaces. Okay, so I have here everything is set up, obviously nicely. So this variable is telling the account tools where to connect to. So if I want to say, okay, what images do I have available? We see we have that private AMI. So let's run it. How many zeros are there? Okay, so I have my image running now. It's not a real image, it's just OpenNebula saying that I have one, but it's not true. Okay, so this is pending. This means that this is more or less what Amazon does. So it means that OpenNebula is waiting for the scheduler to kick in and find a suitable host to deploy this virtual machine on top. So it's already running. Okay, so the nice thing about having the same OpenNebula instance sharing different cloud interfaces is that you can mix and match. So you can, for instance, use the OCCI interface, which is, okay, I'm going to talk a bit about the OCCI interface first. The OCCI interface is implemented very much in the same way. This is a REST interface that is defined by the Open Grid Forum OCCI group, which is intended to be a standard to manage virtual machines in a cloud environment. So we implemented the first draft. This was 1 year and a half ago, something like that. So it's got a bit updated, but there's some people working in the latest revision. So it's basically, as I said, a REST interface, so everything is done using HTTP verbs. So you have a 3 set of resources: compute, storage, and network, and you can perform REST operations on top of that. So you can, for instance, post a new virtual machine to the compute URL, and OpenNebula will then parse the XML that you pass in the body of the post request and will create a virtual machine for you. So, So I have here a couple of examples on how an OCCI request for a virtual machine looks like. So basically here you're saying, okay, I want a compute resource with 4 CPUs, 4 gigs of RAM, this name, this instance type, and I want to use this storage and this network. So you can use this with curl basically, but we provide some wrappers to that. It's OP compute and OK storage and OK network. So we have to verify first that this image exists. So we have the storage number 24 that exists, and also we'll have to check out that the network exists. So it's number 30 and it's also there. So well, we can also request. This is basically all the network pool, so all the networks I have access to. I can ask for details on a specific one. So this network is a public network. It's a public LAN that I created for this tutorial. It has that base address and it's a size C network. Okay, so let's see what compute pool do we have. So this is compute number 40. That is the one that I created with the EC2 interface. So let's create another one. Okay, so I have a new one with a different ID. And let's check if I can see them in using the EC2 interface. So there it is. It worked. Any doubts regarding this? Maybe I'm going too fast. I'm sorry, but I don't have many time, so any crucial doubt or something like that? Okay, perfect. So just to finalize, because I'm running out of time, the new features in version 2.2, it's basically, this is the most showy one, is the Samsung interface. It's intended to end users and system administrators that want to perform all the operations on a private cloud that they can manage. So you can see that there's tags for hosts and clusters, which makes it different from maybe the AWS management console that Amazon offers, because you cannot manage your hosts, Amazon hosts using that. And also gives you the ability to create and use virtual networks, images, manage users, things like that. So, I want to show you just briefly. So this is how it looks like. This is the graphical interface to the same server that we were fiddling with the images beforehand. So just gonna log in with my credentials. So this is all the hosts that are available. These are all fake hosts because, again, this is just an OpenNebula instance running some dummy drivers. You can, do different operations like create new clusters or add new hosts all through this interface. This is also all the virtual machines. Maybe this is a bit shocky because here you can see I'm a normal user and I can see all the virtual machines. But the reason behind this is that this is not a public cloud interface, but a private cloud one. So for instance, if I want to look at my virtual machine, so these are the virtual machines that I just launched. One using the con command, the PC2Query interface, and the other one the OCCI interface. These are all the virtual networks available, and this is the one that I choose for. So here you can see some extended information. Also, you can create virtual machine with a nice wizard. This is like the most difficult thing to do with OpenNebula, is to create a virtual machine template that works. And this greatly helps the user to create their own customized virtual machine. Okay, so I'm out of time. Just to end up, some other new features is we have the image catalog now is exposed through OCCI and EC2. There's a new Ganglia approach to monitorize your infrastructure using Ganglia, which greatly improves the scalability of the OpenNebula solution. And we also offer fault tolerance mechanisms, which are basically those hooks I talked about, and there's hooks for physical hosts, for virtual machines, and the OpenNebula service can be running duplicated. So if one goes down, the other one has all the information needed to keep on managing the cloud. Okay, just saying to end up that this is an open community. You are invited to contribute, to ask doubts in the mailing list, to request an account for the development portal to submit your own requests, and just saying a big thanks to the European Union and the Reservoir project that helped foster the toolkit. And that's it. Any questions? Yes? That's okay.
I have two questions actually. Rather short ones. Do you support live migration of virtual machine?
Yes, but again, you have for that you really need, for instance, for Shen, you need some kind of shared storage.
Mm-hmm. Yeah, this is exactly why I'm asking this. So if you need shared storage for this, and you need to have a synced file system on the other side available for live migration.
Yes.
Okay. The other question was, how about the name? What does OpenNebula means? Or how was the name created, Nebula?
Yeah, well, Nebula, it's, we choose it after, we co-name the releases from nebulas in the sky, so the constellations, basically. But Nebula also resembles, at least in Spanish, something like a cloud. So it's something like open cloud. Not that much more to it. But there's the good name is, I think it's Sandstone. I think that's the good one because I came out with it. And Sandstone is supposed to be, Vikings, the ones that go sailing in the sea from the north, the ones with horns. They used that when there was very cloudy. They had this sandstone, which is basically a clear rock where you can look. So the light of the sun got polarized, and you could see where the sun is, even if it's really cloudy. So that's the name of the face. Thanks for asking.
What about references? Who's using OpenNebula?
Okay, thanks for asking that, because I have my use cases slides here. So just briefly, for instance, this is our biggest success story is CERN. They are using OpenNebula in production, and they made some stress tests to it, and they end up using 400 hosts and 16,000 virtual machines running on top of them, all of them managed by OpenNebula. So this is our biggest success story. We have some other users, like for instance the grid, which is the German grid here, Also an HPC cloud in the Netherlands, it's Sarah, that also developed some of the user interface. We have people from the China Mobile, very interested and already using OpenNebula. And then we have some more users from hosting providers, and all the information is in the web page. If you go to the web page, you will find exhaustive lists of all the users. The difficult thing about this being open and being Apache licensed is that we don't really know who is using us. People download it, but then they don't want to say, we try to make service, but it's really difficult to find out who is really using OpenNebula. We believe more people than we know are using it, but we cannot be sure, obviously. And then there's loads of, well, not loads, but several European projects like Reservoir Days, Just Ending, Forecast, Stratus Lab, which aims to bring the worlds of grid and cloud together, that are also using OpenNebula as a core component for the software stack. Okay. Any more?
Yeah. Are you planning on adding the accounting stuff into Sunstone at some point?
Yes, it's in our roadmap. Definitely. I cannot abide to one specific date, but that's surely going to happen.
Right. And is the accounting stuff available for EC2, public clouds as well?
What do you mean? I mean, if you...
Getting accounting information back off.
Of the EC2 query interface?
Yeah, for example.
I mean, well, not at the moment, but I'm not even sure if Amazon provides that.
Yeah, sure.
It does?
No,
Okay. I mean, we cannot, I mean, we're just using the standard Amazon, well, the de facto standard Amazon is using. If they provide that, then maybe we can think to expose our functionality using that interface, otherwise.
one of the other things I often get asked about is workflow, so sign off for creation of nodes and things like that.
With dependencies and...
For example, I am just an administrator. I don't. For example, if you want to provide an interface to different application groups, creating instances, but you don't want them to just create things willy-nilly, and have some sort of a managerial sign-off for that, or some administrator to sign that off. Is that somewhere in the roadmap for Sunstone?
I'm not understanding fully the question.
So providing the Sunstone instance, for example, to non-admins, who aren't administrators necessarily.
Yeah, that's perfectly possible.
Sure, but adding the ability to be able to have that as a sign-off, so there's actually a workflow that has to be signed off before that instance gets created.
Okay.
Yeah, this is something that vCloud does, I believe. That's why I'm asking it specifically.
Okay, I'm not idea about that. But if that may be interesting. If you could please send an email to the mailing list, exposing just briefly, like a couple of lines, like, would you ever do this? And I try to figure out what you're talking about and answer.
That's why I asked it.
Okay.
And, it's an interesting feature that I've been asked about as well.
All right. If it is interesting, then we'll consider it. Okay. Any more? Well, thanks for paying attention.